My last video, Human Evolution Made Easy, showed how mitochondrial DNA can be used to trace our most recent common matrilineal female ancestor, who lived about 150,000 years ago in Africa. But the same can be done for markers on the Y chromosome, which are only passed from father to son. Our most recent common male ancestor also lived in Africa, but much later, around 60,000 years ago. This video will look at what happened next, and how we know that these ancestors migrated out of Africa and the routes they took to colonize the world. To understand that evidence, we first need to understand these DNA markers. DNA consists of two intertwining strands, which are basically joined up chemicals called nucleotides. Just 4 different types of nucleotide are found on each strand: adenine, thymine, cytosine, and guanine. To glue the two strands together, adenine always pairs with thymine, and cytosine always pairs with guanine. That's just the nature of their chemical bonds. When DNA copies itself, the copies aren't always perfect. So sometimes the wrong nucleotide will be put in place, in this case adenine instead of cytosine. If that isn't corrected, the pairing nucleotide will also be wrong, so you've got yourself a mutation, a marker. If the marker is on mitochondrial DNA, that marker will be passed down through every female descendant without alteration. If it's on Y chromosome DNA, it'll be passed down through every male descendant without alteration. So if we find a marker in people today, we can trace it back through thousands of generations to find out when and where it started. Now imagine if all these people were migrating. This group stays put, this group moves north, and in this group, headed east, a baby boy is born with a unique marker on his Y chromosome. The baby grows up and has male children who also carry the same marker. As the group continues its migration, some tribes settle and others keep moving eastwards. Like a leaky boat, the movement leaves in its wake a trail of descendants with the red genetic marker. So by checking the DNA of people living today, we find those with the same genetic markers. This map shows the distribution of men with a marker on their Y chromosome called M130. We can wind this film backwards and follow the migration route they took, which was the first complete one out of Africa around 60,000 years ago. That was the basis for the study conducted by Spencer Wells and others in 2000, which involved collecting DNA samples from indigenous people all over the world. Wells found distinctive genetic markers and traced each back to its source, marked here by red circles. We're retracing the migration paths our ancestors took backwards through time, and this is where they started, once again in Africa. Because the mutations happen at a fairly regular rate, these ancestral markers can even be dated, so the timescale on this map marks the progress of each migration. Populations that stay put and don't migrate will, of course, have a lot more of these genetic markers, so it's not surprising that we find the greatest genetic diversity in Africa. But the greatest of all belongs to a people whose ancestral homeland once extended from South Africa to the Rift Valley. Wherever you're from in the world, whatever mitochondrial or Y chromosome DNA markers you have, you can trace your ancestry back to the people whose modern descendants are the San, the Bushmen, the living embodiment of all modern humans. DNA evidence coincides perfectly with climatological evidence that shows these migrations occurred when East Africa was wetter and the Sahara was a savanna. Humans followed migrating herds across it, but when the climate became drier, the Sahara turned to desert. Effectively, it slammed shut like a gate. When the Saharan climate improved again, DNA evidence, coincidentally, shows a second great migration. This was the big one. Our ancestors moved into the heart of Europe and Asia, then later across a land bridge into the Americas. Wherever they went, humans adapted to the climate and new diets. People moving into northern climates lost the melanin in their skins. Melanin inhibits the production of vitamin D by sunlight. That's no problem in sunny Africa, but a drawback in northern latitudes. As long as they were moving and opening up new territory, there was plenty of space for excess populations to expand. But around 20,000 years ago, the human diaspora had filled nearly every continent. Settled populations began to grow. What we learned in primary school is that Stone Age humans were hunter-gatherers living in small tribes. Then all of a sudden they discovered farming, settled down, built towns, and invented writing. But if humans have been around for over 100,000 years, why did they suddenly become civilized in different parts of the world at the same time? Fundamentalists point to this primary school explanation as proof that our species is very young. But of course, if you don't look beyond simplified explanations, you never gain more than a simplified understanding. Archaeologists don't see civilization as something that appeared out of the blue, like a light suddenly banishing the darkness of the Stone Age. Instead, they see increasingly complex and hierarchical societies. In Europe and the Middle East, people were living in semi-permanent settlements 20,000 years before the first pyramids were built, and 12,000 years before farming was discovered. They had art, culture, religion, medicine, and a growing technology. They mass-produced beads and mined obsidian and flint for export, then transported them over extensive trading routes. They crisscrossed the Mediterranean in trading boats, and far from having lives that were nasty, brutish, and short, most of them lived to be grandparents and enjoyed healthy food surpluses. Even 6,000 years before farming was introduced, people in northern Mesopotamia were living in sophisticated settlements. This is a temple complex dating back 11,000 years. Further south, a people called the Natufians were also living in permanent villages, and there's evidence they stored grain. But then came the next big change. In the Middle East, the climate dried. Whether people began planting crops because they'd become scarce in the wild, or whether scattered populations had to congregate around oases and rivers because water was scarce, whatever the case, farming seems to have begun out of necessity. Over several hundred years it took hold in Mesopotamia and the Yellow River Valley, apparently independently. It took 1,000 more years for the practice to spread via trade routes to the Indus Valley, the Nile Valley, and other parts of Eurasia. But the payoff from farming was huge. It opened the way for larger settlements, technological innovation, and accelerated trade and writing. The motivation of these megalithic and Neolithic people may always be debatable, but nothing contradicts the hard evidence of DNA. Tracing our ancestry uses exactly the same techniques used in determining paternity and convicting criminals. If fundamentalists want to reject the techniques that prove our origins and migrations out of Africa, then they have to reject the same DNA techniques that help convict rapists and murderers. Now that's a tough call for evangelical preachers. The DNA evidence also fits perfectly with the climatological and archaeological evidence. We have a lot more to learn, but we do at least know how we got here. And so we come to the present day, having traced our origins in this series all the way from the Big Bang. Of course, to use a cliché, this is all ancient history, but to those with a yearning to know who they are and where they came from, it's a history that made us who we are. To understand that, just look at Britain's oldest complete skeleton, 9,000-year-old Cheddar Man. In 1997, DNA was taken from the skeleton and compared to people from the area. They discovered one of Cheddar Man's direct descendants, a schoolteacher, living just half a mile from where the skeleton was found.